Howdy folks, and welcome back to another lesson in Ocaml. This day 2 that's been long awaited for about 2 years now is going to be covering for loops and if-then-else statements. So without further ado, let's just jump into it. So one of the first things that I want to talk about is in this lesson we'll be setting you up for some success. So like our master functional programmer here, McCree, we're going to learn some tips and tricks about Ocaml that's going to help us down the line. So we're going to focus on that.
How do you like me now?
We're going to really like what you see with the Ocaml stuff. So without further ado, let's get on to some answers that we've seen from the last video. So the first thing, when we talked about assigning a variable x that's equal to 7, pretty basic here. We just say let x equal 7 and we have our integer. Additionally, the add2 function takes parameters x and y, adds them together, and if you pass in some values, like I have here with 3 and 4, you'll notice that we get 7 back as the result. So everything seems to be working fine on that front. So then what about the concatenation string, that little function that we had been working so hard on? And that function, you can see we have 2 strings here, and we just concat them with the little caret symbol. And sure enough, we have experience tranquility down here as 2 separate strings, and we get the full result once we pass it in to concat this. So some pretty basic functionality, but it's always good to kind of start out with the basics to get more comfortable with a language. So that brings us into a little bit about Ocaml. So you might see that when we have these Ocaml files, we're saving them as .ml files. And what the heck is that? So these ML files are known as modules, and the modules is something you could refer to as, in the case of a library in Java or C#, for example, you might see import some library in Java, or maybe the keyword using for C#, or a variety of other cases. Essentially, what we use in Ocaml is we use open, and then we give the module name that we want to use. So if we create some ML file and we have some functions that we want to use in another ML file, we would open that module within that ML file. So if we wanted to use maybe those functions that we just created, like concat this, and we saved it in something called test.ml, we would open test.ml in our current ML file in order to use those functions. So a very similar functionality to the using and imports from Java and C#. So then let's get on to this business of if, then, else, and for loops. So first of all, how the heck do they work in Ocaml? Because we love them in our object-oriented languages. And second of all, how often do we use them? And that's something that we might be surprised to see in a functional language, is that they do exist, but they don't have the same amount of power as they did in Java, C#, and C. We have our uses for them. Of course, using a conditional is pretty popular for most programming senses, but we'll see that match cases are a little more powerful, and they do some cool stuff. So put if then else on the back burner, and we'll get into match cases, and you'll start to see, hey, this is actually pretty cool for a functional programming language. And then for the for loops, that's something that maybe some of you are dreading. If you took an intro class to programming, you probably got those for loops and you thought, hey, this thing's pretty cool. We go through it and we execute everything X number of times, and then we exit it. It's all good there. And then they introduce this idea of recursion, where you call the same function over and over again, and you basically build it on the stack. If you've seen that before. If you haven't, don't worry about what I'm saying. Just kind of move on, or just forget it for now. We'll get into it in depth later. But unfortunately, recursion is going to be your best friend when it comes to functional programming. So if you're dreading it, get more comfortable with it and realize that it will probably only be this one semester that you have of a functional language that you really have to deal so much with it, and it will kind of take a back burner for the rest of your programming career. Unless, of course, you build recursion within your programs, which also is highly recommended, but that's neither here nor there. Recursion is going to be your friend here is the main idea. So before we get into those things of match cases and recursion, let's just talk about for loops and if-then-else statements, just for our sanity. What do they look like in Ocaml, and can I use them, please? Yes, you can use them. So we have a simple print loop function here that takes a variable x. And what we want to do is we have this on line 5, this for loop. And you can see that it actually reads a lot like pseudocode, where we're just saying for I equals 0 up to x, do something. And you'll see that we lack the brackets that we might have seen in other languages. And our brackets are almost replaced by this do and done that you see on line 11. So you can think of those almost as our fake brackets, if you want to look at it that way. And within these brackets, we have this if, then, else statement. And you can actually read this, and it reads pretty clearly. Line 6, if I, so our current iterator, mod 2 equals 0, which is just basically saying, is this an even function? Then we're going to print even, and we're going to print that number. And as you can see on line 7, we have the %d, which you might be familiar with if you use Java, which is just basically saying, hey, there's going to be an integer in here, and I is going to be that integer, so we're going to print I. Otherwise, if it's not even, we're going to print this very true statement of this number can't even, and we're going to use I again in that case. So that's an important thing to note, an important thing to realize here is we have this if-then-else statement and a for loop that we can use. And if we run this, we'll see pretty much what we'd expect. So you'll see up here this hashtag use, and then in parentheses, print if loops, if-end loops.ml, and the 2 semicolons. And this is just basically a way to tell the REPL that you're going to use a file that you've created. And you can see if it reads through correctly and it's happy with it, it will tell you the name of the function, what it takes in as a parameter, and what it will return as a result of going through the function. And as you can see, in this case, we only have one function here, but if there was an error that existed in the function, then we would basically get an error, so we kind of could go back and fix the code. So now we run the function, and we basically run the function by saying print loop and passing in that integer, and you can see we pass in 20, and the results are as expected here. I won't go through all of them, but there you go. So now, going on beyond the if, then, else statements and the for loops, we're going to talk about local versus global bindings. And this might be something you had some exposure to in the object-oriented language class, but we're going to go over it again in Ocaml, and we're going to take a look at this kind of nasty-looking example here. So we have this original string declaration up here where we set this variable hello equal to hello. That makes sense so far. And then we have this amalgamation of crap that we don't really know what the heck it's doing. And the answer here is that this Beatles variable is actually going to be a string. And all this crap in here is going to give us that string. So the first thing we do is we have a local variable goodbye that's equal to the concatenation of this hello variable up top and a new string goodbye. Then we have another hello variable, and this one's kind of weird because is it this one? You know, are we using this? Are we reassigning it, or what's going on here? We'll get into that. Don't worry. But you can see we use hello and add hey onto it. And then finally, we have another goodbye declaration, and we add goodbye onto goodbye. And then at the very end, we do hello goodbye. So there's a lot of crap going on here. There's a lot of stuff, and it's really confusing, kind of daunting. But what the heck is this going to print at the bottom here? Is this Beatles going to print hello goodbye? Is it going to print hello goodbye goodbye? I mean, what is this going to do? Is it going to crash out? Has Ocaml had enough of us? Well, let's take a look at what's really going on. And if you want to give yourself a challenge, pause, think about it, and then click play, and we'll go over the results. And I'm assuming that you've clicked pause by this point, so we're going to go over the results now. So this is the results of what happens here. And as you can see, the first thing that happens is in this goodbye, we set it equal to hello goodbye, which follows pretty much with what we're thinking of logically here. We have a hello variable and our goodbye variable. So hello goodbye is going to be set. Goodbye is going to be set to hello goodbye. Then we have this hello over here, and we basically take this hello up here and add on hey to it. So we get hello hey for our local variable. That's all fine and dandy. I think we're all on the same page so far. We get to this goodbye here, and you notice that the original goodbye we had was hello goodbye. So we're just going to add a goodbye onto that, and we'll get hello goodbye goodbye. Starting to get a little dicey here, but you know what? Let's just get to this last one and see what happens. So now we concatenate hello and goodbye, and what are the results going to be? Because this is ultimately going to be that Beatles variable. And what you notice is that hello hey is used, which is what this second declaration of hello is within this Beatles variable. So we do actually have hello being used here instead of using this global hello up here in order to get this final result, hello hey hello goodbye goodbye. And if we print the results here, you'll notice that we get hello hey hello goodbye goodbye. And if we print hello, we just get hello. Why is that? Why are we getting just hello? And the reason is because this hello is locally defined, whereas this hello is globally defined. So we can't reference this hello outside of its existence within this Beatles variable. So if we tried to even reference goodbye, we get an error because it's all within this local Beatles variable. So we can't actually do anything with these variables here. But we can print this hello. And as you can see, if we run it, you'll see the results right here. So now, in order to kind of speed things up, or in order to kind of demonstrate some things, I'd like to go over a brief, realistic example. In order to do that, I'm going to open up my VM here. So we're going to launch into this VM, and we're going to take a look at, if I can get my password correct, we're going to take a look at some code that I had written here for Ocaml. So I highly recommend Visual Studio, first of all, and downloading an Ocaml extension to writing some nice, clean Ocaml code. But let's just kind of go over what we kind of some discussion points. And this is all going to be in GitHub. I'll leave a link in the description. But basically, you can go on GitHub and grab this and do whatever you want with it. But let's just kind of go over it one at a time. And if you're not interested, you can skip towards the end of the video where we'll have some questions that I'll leave you with. So first of all, we have this math function that takes two variables, x and y, and we add them together, and then we basically double the summation of x and y. Pretty basic, no big issues there as far as I'm concerned. And it kind of just follows another basic function, but it helps to kind of look at these things. Then we have this repeat alt print that takes an integer n and two strings yin and yang, or as I've kind of learned recently from some fellow Chinese friends, it's pronounced yang, but I'll stick with the Americanized version for the sake of consistency here. So yin and yang will basically, again, it's another even check as we kind of go through this, and we print back and forth yin and yang. So whatever those strings are going to be, we'll print each one kind of one after another. Then finally, we have this example here of the Beatles and hello variable. And one important thing to note is that if we wanted to reference this goodbye variable, what we would want to do is we'd maybe want to take this whole line and put this bad boy up here on line 29, and then we can reference printf goodbye. So let's take a look at that in the terminal here. And while I'm doing that, I'm going to actually briefly mention something that I really think helps for Ocaml experiences. And that is that you can use Ocaml, and you'll get this nice REPL here, but one of the things that is kind of frustrating about this REPL is, let's say we want to, for example, use day2 local global.ml, and then type that in, and don't forget our semicolons, and there we go, we have it. It's not necessarily as easy to do, and especially if we get longer file names, it's going to be a pain in the butt to use. So what we'll do instead is we'll use something called utop, and when we open up utop, you'll see that it's got a nice pretty color to it, nice and fancy, but most importantly, if we try to do something like use, and then we want to use this, we can actually use tab to finish our statement, and it will just fill in everything for us, and we'll get this really nice looking list of all the functions, which I guess we did get up here, but it's much easier to use that tab auto complete than it is to write it all out, especially when you try to use arrow keys in the REPL, which is a pain in the butt. We won't even get into that one on that front. So I highly recommend utop. You install it the same way you would Ocaml, sudo apt install utop. It's very easy to do on a Linux machine, and if your schools are anything like the University of Minnesota's, we had Linux, so it was very easy to install that. Or if you're just using a virtual machine at home, highly recommend giving Linux a shot and doing your coding there. Very helpful for programming and learning programming. So now let's try using some of these functions that we've written. So for math, let's just give it a simple 2 and a 5, and we'll finish that off. And you can see 2 plus 5 is 7, 7 plus 7 is 14. So we get the expected result there with 14. Now let's try repeat alt print here, and we'll give it an integer of, let's just say 6, so we get 3 of each. And we'll give it 2 strings, and we'll call one Ocaml, and we'll call another utop, and we'll try printing that one. And as you can see, we go back and forth between utop and Ocaml, which is what we were looking for, so we're all good on that front. And then finally, if we represent, or if we ask Ocaml to give us that hello variable, we're going to get hello back. If we ask it to give us the Beatles variable, we're going to get that hello, hey, hello, goodbye, goodbye variable that's so nicely spaced and printed. Just kidding on that front. Not a very good teacher on that front, but I apologize for that. However, one last thing that we'll do here before we end this session is we'll basically run Ocaml, and we'll kind of go over some quick things. So in order to compile a file in Ocaml, you'll use Ocaml-C, then -i, and we can use this day2 local global, and we should be able to compile it fine. Ocaml will tell you the functions in it, and then if we want to run it, we'll just say Ocaml, and then we'll use this function or the file, and we'll get those results that we've seen before. So that's just a brief overview of some command line stuff with Ocaml and using utop. Again, highly recommended that you use that, and highly recommended you take a look at some of this stuff and start getting more comfortable with Ubuntu and Linux, because even if in a business world Windows might be dominant, as far as learning programming, Ubuntu is very powerful and very fun to use, and Visual Studio can be used on any platform, or Visual Studio Code, that is. So thankfully, you can still have this nice Microsoft product, which I highly recommend, but you can always use other stuff if you're interested as well. Anyways, that's besides the point. We'll go back to finishing our presentation here. So we will leave off with where we'll present from the current slide here, and we'll go into the questions that we have here. So projects and questions. So about the projects would be something I would like to do, and I would like to create some projects at some point to kind of give you a better understanding, to optionally let you work on them, and hopefully get some more experience. If that's something that's of interest and I see people are interested, I might put some time into that. However, at this point, given that my channel is pretty tiny, and we just got a few hundred people that looked at the first Ocaml video, I'll just stick to these questions and just kind of powering through Ocaml some more, and try to continue to help out, because I know there's not a lot of videos on Ocaml out there. So let's just jump into those questions then at this point. And question number 1 would be, how would I get the local value hello to be a value I can reference globally? So you remember that back here, this hello that exists inside the Beatles function, that's hello hey, as it should say, how could I actually print that out here? Feel free to change the variable name if that helps, but we just want this hello hey to basically be referenced, where we can print f it outside of the Beatles function and still use it. And then the second scary seaside question that I put in blood red coloring here is, I've framed this to look like a scary theory question, because you might have already taken a theory class, or you might be planning to, and if you're planning to, you'll see these theory looking questions a lot, and if you're anything like me, they look very scary, and you start to overwork yourself just trying to figure out what's going on, when really the question is pretty simple. So what I want to do is I want to basically frame it as a scary looking question, and then break it down into a not so scary question, and realize, wow, this is actually really easy. So let's just get into the scariness of it. We say, let n be the integer I'm comparing against, where if a value x is greater than n, I will print this pompous phrase of x is superior and therein better than n. Otherwise, if x is less than n, I'll print x is merely a menial subject to the vastly greater n value. So while pompous and kind of egotistical, there's really not a whole lot going on here, and this is actually very basic. As you can see in the hint that I've said, it's a very basic and simple demonstration of the if-then-else function. So it's framed as a scholarly theory question, but like I said here, knowing how to break that down is what helps you earn a degree in computer science. So give it some thought, think about what really is being asked here, and take some time to figure that out. And if you can figure it out, or you need some help, look forward to the next video. I'll be posting in 2022, and I'll have some answers to this stuff, and we'll see what the results are. Anyways, I hope you enjoyed watching, and I will see you folks in the next video. Thank you for watching.